Number 18 is dealing with a big yo-yo, and we need to find the acceleration of the yo-yo. Now, there's this big hubbub in this chapter about smoothly rolling acceleration on a ramp, and as I discussed in the notes, or in the lecture notes, the acceleration on a ramp is a strange formula. It's sort of a complicated looking formula that I derived. Um, and a yo-yo is essentially a vertical ramp. So the only difference in the equation that we're going to use, by the way, this is part A. The only difference in the equation, because it's a quote-unquote vertical ramp, is that sine of the angle is 1. So the only thing that a yo-yo is missing then from a normal ramp problem is the sine theta here, but that just becomes 1 because of the angle. So we're not going to write sine theta, and on here in the bottom we got plus I over mr squared. This is the I, the moment of inertia, the rotational inertia of the yo-yo, and this is for the pivot, for the little axle radius. Alright, so let's plug some numbers in. First we got to find the I of a disk, and that happens to be, if you look up on that table way back in chapter 10, 1/2 mr squared. Oops. And so this is pretty easy to find. This is just 1/2. 1/16 is the mass. By the way, in the book it says the 116 kilogram yo-yo consisted of 2 uniform discs. 116 is both discs, so that's just, you can kind of ignore the whole 2 discs thing. Just essentially treat it as 1 disc. And the radius of the discs is 0.32 meters squared. We converted that from centimeters to meters. So that just gives us an I of 5.9392, and that's what we're going to stick right in here. This is a kilogram meter squared. So this becomes negative 9.8 over 1 plus 5.9392 over same mass, 116, but this time the R, because as I derived for you, the tension is acting on the edge of the axle, not the very edge of the yo-yo, and so that is has a radius of 3.2 centimeters, or 0.032 meters squared. And that gives us the magic number of negative 0.192157 meters per second squared, but it wanted the magnitude, so we'll just do 0.19, we'll round also, meters per second squared. So that's the acceleration of the yo-yo. Part B asks about the acceleration on the way up. It's the same angle ramp, nothing changes in here, so same. Part C, we need to find the tension, so that's net force equation. F net is ma net, which we just found here, and that equals Ft going up minus Fg going down. So 116 times 0.19 equals Ft minus 116 times 9.8. That gives us an Ft of 109.9 newtons. And then part D asks, was a tension near the chord's limit of 52,000 newtons? Not even close. No. Part E asked, will the magnitude of the yo-yo's acceleration as it falls be greater than, less than, or the same as that of the San Francisco yo-yo? Again, the acceleration depends not on, well, it does depend on the mass, but that cancels out here, right? This 116 and this 116 cancel, so nothing in this equation changes, so it's the same. But what about the tension? So tension depends on, as you can see, mass here. So if the 116 becomes bigger, or if this mass becomes bigger, then the tension becomes bigger. So it's a direct relationship. As mass gets bigger, tension gets bigger. Alright, and that's it. Not too shabby.